Hi ladies, in this video we're going to go through the difficult questions for 6C. So that's index law 3 and the zero power. So the previous video went through these questions and these key ideas, but I might just quickly touch on these key ideas for you. So the first, index law number 3, or the first dot point, is when you have the base to a power and that is also taken to a power, what you do is you multiply your powers. The second dot point is the zero power. So anything, no matter how big it is, if it's negative, if it's a fraction, whatever, if it's to the power of 0, it will always be 1. And just this little note here, that means a is not equal to 0, because if a was 0, it would just be 0. Okay, so 0 to the power of anything will always be 0. Okay, so let's go through some of the difficult questions. So question 7. There are 100 rabbits on Mount Burrow at the start of the year 2000. The rule for the number of rabbits n after t years from the start of the year 2000 is n equals 100 times 2 to the power of t. So first of all, find the number of rabbits when t equals 2, t equals 6, and t equals 0. So let's just... Okay, I just had to reopen Word because if I open Word and I don't connect my tablet, sometimes the little draw function doesn't come up. So I just had to restart it. Okay, so now I can write the question. So we're looking at question 7 first. Now I'm going to write the equation. So n equals 100 times 2 to the power of t. So part 1, we're looking at t equals 2. So it's just a straight substitution. So n equals 100 times 2 to the power of 2. So 2 to the power of 2, it's just 2 squared, so times 4. So you've got 400. The second part, we've got t equals 6. So I might just scroll up. So n equals... buttons on my pen sometimes press it. N equals 100 times 2. Now, t is 6 for this question, so it's 2 to the power of 6. 100 times, now 2 to the power of 6, if you think of it in expanded form, is 2 times 2 times 2 times 2 times 2 times 2. So you're multiplying 2 by itself 6 times. So 2 times 2 is 4. So we're basically doubling each time. Times 2 is 8. Times 2 gives you 16, 32, 64. So it's 100 times 64 gives you 6,400. Okay, the third question is when t equals 0. Now, often you'll see questions like this, and you have to do t equals 0. Because you need to know what it is initially. So the word initial means at the very beginning. So how many rabbits did we have on Mount Burrow at the very beginning? So 2 to the power of 0 is 1. So we had just 100 rabbits to begin with. And then after 6 years, that'd be 6,400. After 2 years, 400, and so on. Okay, the next part of the question, find the number of rabbits at the beginning of 2003, 2007, and 2010. So let's do the first one. So 2003. Now, this requires us to see what n means. So what t means. So t years from the start of 2000. So 2000 is t equals 0, okay, at the beginning. 2001 is t equals 1. So 2002 is t equals 2. And 2003 is t equals 3. So we're substituting in t equals 3 for 2003. So n equals 100 times 2 to the power of 3. Now, 2 to the power of 3, remember that's just 2 multiplied by itself 3 times. So 2 times 2 times 2, which is 8. So we're going to have 800. I'm going to need some more space, so let's just get rid of all that. Okay, so B part 2, I'm not going to do all of them, but this is going to be t equals 7, so you'll be able to substitute that in. And then part 3 is t equals 10. So I'll let you finish them. Oops, not C, that was B. Okay, see, how many years will it take for the population to first rise to more than 500,000? So we want n to equal 500,000. So this is a little bit harder. So we're going to, instead of substituting for t now, we substitute in for n. So we're going to have 500,000 is equal to 100 times 2 to the power of t. Now we just need to get rid of that 100 first. So we want to get t by itself. Now, if you didn't have a calculator, dividing by 100 is just getting rid of some of your zeros. So we've got 2 zeros there, and they can cancel out with those 2 zeros. So now we're left with 5,000 equals 2 to the power of t. Now you can't divide by 2 to get t, okay, because that's not a multiply, it's 2 to the power of. Sorry, there would have been just a little glitch there. So you could solve this using a calculator, but at year 9, you will need to think, well, how else can I do it? What skills do I have that will allow me to solve this? So you can always set up a table. So, oops, it's just had it on eraser. You've got values of t. So if t was equal to, let's say, 1, and then we've got 2 to the power of t. So 2 to the power of 1 would be 2. Then t equals 2, we're going to have 4, 8, 16. So we're basically doubling each time. So we need to keep going until we get to 5,000. So 5 is 32, 6 is 64, 7 is 128, and you can keep going. So I'm going to pause and keep going. Okay, so I've finished this off, and at 12 we get 4,096, at 13 we get 8,192. Now remember, we're solving for this equation. Okay, so we simplified it to make it a little bit easier. So if you're wondering why we don't see 500,000 there, that's because we divided through the 100. So if we had t equals 12, we're not going to have enough rabbits. Okay, so when t equals 12, n is going to be equal to 4,096 times 100. So just add another 2 zeros on. But when t equals 13, n is going to be 819,200. So that means, because we've got to give it in whole years, if we said 12, okay, obviously 409,600 is closer to 500,000, but you don't quite have that many rabbits there yet. So your final answer has to be t equals 13. Because after 13 years, we definitely have more than 500,000, but after 12 years, we haven't yet made it. Okay, question 8. If m and n are positive integers, in how many ways can a to the power of m times n equal 16? So this is just looking at your factor pairs. So we want 2 numbers, so we don't have to worry too much about the base. We just need 2 numbers when multiplied give you 16. Okay, so you can have obviously 1 and 16. You can also have -1 and -16. You can have 2 and 8. Oh, sorry, I just read that they're positive integers, so let's get rid of that. So we can have 2 and 8. What other factor pairs do we have? We have 4 and 4. Now, m and n, even though they're different letters, they can actually be the same number. So you can have 4 and 4. And if you want, we can do the reverse factor pair. So you can have 16 and 1. So this time m is 16 and n is 1. We can have 8 times 2. So I guess there's 1, 2, 3, 4, 5 different ways that we can do that with positive integers. Remember that integers means whole number, and obviously positive, we're just looking at the positive ones. Otherwise, you could also have the negative values here as well. All right, question 9. Let's get rid of that. Evaluate these without using a calculator. So let's have a look at 9a first of all. So 2 to the power of 4 to the power of 8 divided by 2 to the power of 30. So using a number of index laws here, so we're multiplying these powers. So 4 times 8 gives you 32. I prefer to write my division as a fraction. Okay, so now we can easily cancel these powers out. So remember, when you're dividing, your powers are subtracted. So 32 minus 30 gives you 2. So we're left with 2 to the power of 2, which is 4. So it says evaluate. So we need to put it into a whole number and not leave it in index form. All right, let's do a harder one. So I'm going to do 9D just because there's some negatives involved. Oops. It's a funny way to write a D. Negative 1 to the power of 11, and that's to the power of 2 times negative 1 to the power of 2 to the power of 11. Okay, so negative numbers, and I remember doing this with my Year 7s earlier this year, so you may remember, hopefully, if you can go back to Year 7, that when you've got a negative number to an even power, okay, so to the power of, I was pointing to the 11, so to the power of 2 or to the power of 4, 6, 8, whatever, you're going to get a positive answer because you're going to have a negative times a negative. If it's to an odd power, so 11 in this case, you're going to have a negative answer. So for this question here, we're going to keep the base as negative 1, and then we've got 11 and 2, so it's just to the power of 22. Now, I like to put my negative numbers in brackets just so we remember that negative there. And on this side, we've got negative 1 as our base as well, and then 2 times 11 again. Now, they're both 22 and 22. They're both even numbers. So I'm going to keep that as negative 1 just so I can show you if it was a different base that we add our powers. So 22 and 22 gives you 44. But because we're dealing with a number 1, 1 to any power will always be 1. But when you're dealing with negative 1, it will become negative 1 if it's an odd power, and it'll become 1 if it's an even power. Okay, I feel like I'm trying to think, did I say that right? Negative 1 to an odd power will stay negative 1. Negative 1 to an even power will make it 1. So here we have an even power, so our answer is going to be 1. And when you think about that, negative 1 times negative 1 gives you 1. So basically, we'd be doing that 44 times, or an even number of times. So that gets rid of that negative. All right, let's do F because it looks like it might be a little bit complicated. So A to the power of 2 to the power of 3, B to the power of 4 to the power of 7, B to the power of 7 to the power of 4, A to the power of 3 to the power of 2. Okay, so do your powers first. So let's do A to the power of 6. Remember, we're multiplying. And while we're doing that, I'm going to say there's a multiply. So we're multiplying the numerators and the denominators. So I'm going to do B as well. I'm not going to keep that multiply sign. So B to the power of 7 and then to the power of 4. So we multiply our powers. So 7 times 4 is 28. And then I'm going to keep it in the same order. So I'm going to put the A first. 3 times 2 gives you 6. And then 4 times 7 is 28. And when you have the same number on your numerator as you do on the denominator, and it doesn't matter that we're working in terms of A and B here, they're exactly the same thing, we get 1. Okay, so simplifies to 1. All right, let's have a look at the other questions. Explain the error made in the following problems. Okay, so I might just quickly explain the error for you. So you can see in the first one, we've got 4 and 5. What they've done is they've added the powers instead of multiplied. So instead of a to the power of 9, it should be a to the power of 20. For B, what have they done? So they've actually squared the 9 as well as the x cubed. So the 3 is separate to itself. It's not to the power of 2. So this 9 should actually be a 3, and the x is fine. That is x to the power of 6. This one here, to the power of 0. So anything to the power of 0 should be 1. So their error is they've only done x to the power of 0, but it's also the 2 to the power of 0 also. So your answer should be 1 for that as well. Okay, question 11, simplify these by first working with the inner brackets. Leave your answer in index form. Okay, so this isn't that difficult. Maybe I'll do the fourth one. So we've got a squared 4, 3, 2, 4, 3. I'm making sure I did it right. And then a 2. Now, effectively, this is just a to the power of 2 times 4 times 3 times 2. It did say work with your inner bracket first, okay, but that's just to make it easier for you to multiply. So it is 2 times 4 times 3 times 2. So 2 times 4 is 8. 8 times 3 is 24. And 24 times 2 gives you 48. For the next one, same thing. You're just now working with powers that are letters. So the first one and the others aren't too different. Oh, actually, let's do the third one because I feel like that's a little bit more challenging. Okay, so we just multiply our powers. So it's going to be x to the power of 2y times 3z. So multiply those coefficients. So 2 times 3 gives you 6. And then we've got yz. I was just thinking in my head, the alphabet, making sure they're in alphabetical order. All right, girls, catch you later.